topic in algebra. So I'm sure you guys know about exponents, but just really quick, let's say we had an expression like this, a raised to the power of b. The b would be acting as the exponent here. It's the guy that's hovering on top, and a would be the base. The base holds everything in place, or else everything would fall apart. So yeah, this would be the exponent, and this would be the base. So if I had an expression like, let's say 2 cubed, what this is telling me is that I have 3 of these 2's, and they're all being multiplied together. So we could rewrite this as 2 times 2 times 2, and then we know that 2 times 2 would be 4, and then 4 times 2 would be 8. So this is another way that we could represent what this is trying to tell us. This symbol here is just letting us know how many of this quantity we have. And it doesn't always have to be numbers. So I could go ahead and write something like a to the 4th power. So now in this case, the 4 would be acting as the exponent, and the a would be the base. And what this is telling me is that I have 4 of these a's. So yeah, just a little refresher on exponents before we get into the laws. You have the base and the exponent, and that's pretty much it. And the exponent just lets us know how many of that base we have. So let's go ahead and start with the first law of exponents. Okay, so now that we reviewed exponents a little bit, let's go ahead and get into the laws. So the first law I want to look at is it's called product same base. So let's say I had b to the 3rd power, and I had b to the 4th power, and wow, that is an ugly 4. Let me just rewrite that. And I didn't mention that these exponents are also referred to as a power. So here, this is b to the 3rd power times b to the 4th power. And notice that we have the same base here. They're both b's. So it turns out that when you have the same base and you want to multiply them together, so hence product same base, what you do with the exponents is you add them. So since we have the same base here, I'm just going to go ahead and write that once. And what I'm going to do with the exponents is add them. So 3 plus 4, and then this would reduce down to b to the 7th. So that's how we're going to go about dealing with exponents when we have the same base and a product is happening between them. You don't have to do this middle step. I was just trying to show you that's what we do with the exponents. So why is this how it works out? So what this is really telling us is that we have 3 b's here. So let me just go ahead and write that out. So this is coming from this guy, and that's getting multiplied to 4 other b's, right? 1, 2, 3, 4. So we have 7 b's here, right? And that's what the exponents we said represented in the beginning. So really here I have 7 b's. Right, because we said the exponent represents how many of that base you have. So really this is why the product same base rule works. And it does have to be the same base for it to work, right? So for example, if I had something like this, b squared times c to the 7th. See, in this case we have 2 different bases. So there's nothing we could do here. You can't simplify this or combine anything. So it's crucial to note that it does have to be the same base. And again, it doesn't have to be variables. We could use numbers. For example, if we had 7 to the 2nd power times 7 to the 4th power. Notice we have the same base again, which is 7. So we're going to go ahead and write that once. And what we're going to do with the exponents is add them. So 2 plus 4. And this would be 7 to the 6th power. And I don't have a calculator on me, but you would just put that in a calculator or something. So this is product same base. It's pretty straightforward in my opinion. It's just be careful to note that you have the same base, because that's the only time you could use this law with the exponents. Alright, so start working with the product same base. I want to get into a little bit difficult example before we move on to the other laws. So here, it's all multiplication all the way throughout, right? So bases individually. So here notice we have the a's that are a common base. So I'm going to go ahead and write the a's. Just going to write the a just one time. And what we're going to do with the exponents is add them, right? So that's going to be 5 plus 2. So that takes care of the a's, right? Moving on to the b's. Let me just go ahead and write the b's once because I notice I have the same base. There's no exponent on this guy, but we know when no exponent is indicated that there's a 1 there. So then 3 plus 1, because we're going to add the exponents from these same bases coming from the b. Okay, and then just simplifying that a little bit more. 5 plus 2 is 7, and then 3 plus 1 is 4. So when you have multiple bases, you just treat them separately. Now we're going to move on to dividing with exponents. So let's say we had a to the 5th power divided by a to the 3rd power. So now notice that the division's happening between the same bases. We're just going to write we notice we have the same base, so we're just going to go ahead and write that once. And what we're going to do is subtract the exponents starting from the top. So it's going to be 5 minus 3. And then 5 minus 3 is 2. So yeah, when you multiply with the same base, you add the exponents, and when you divide with the same base, you subtract the exponents. So let's go ahead and see why this rule works out the way it does. So a to the 5th, this is the base, and this is the exponent. So the exponent tells us how many of this base we have. So we have 5 of these a's on top, and 3 of these a's on the bottom. So 1, 2, 3, 4, 5 a's on top, and then we have 3 of them on the bottom. 1, 2, 3. Okay, so we know from division that we could cancel out the same thing, or simplify stuff down, right? So these a's right here would cancel out, these a's would cancel, and these a's would cancel. So we're just left with 2 a's right here, and that just brings us back to the product same base, right? Because we have the same base here, and the exponents are 1s. And we said when we have the same base, what we do with the exponents is we add them. So since I have the same base here, I'm just going to go ahead and write it once. And then 1 plus 1 is 2. So we end up getting the same answer. Okay, so still doing division with the exponents. So let's just go ahead and do one more example before we move on to the next law. Okay, so I notice I have the same base here, and it's indicating division. So I know when that happens, I have to subtract the exponents. So instead of writing the base twice, I can just go ahead and write it once. And then what we're going to do with the exponents is subtract them. I know I said you do the numerator, subtract it from the denominator. So if it helps you to rewrite this, because in the slash format, so we have x to the 7th. Instead of writing this division symbol, you could denote it. You could also use this symbol for it. Either way, 7 minus 3. But here you can see it better. This is the way I showed you in the first example, so you can rewrite it like this if it makes you more comfortable. So it's always going to be the top minus the bottom, 7 minus 3. And we're going to write that same base just once. So 7 minus 3 would be 4, and 7 minus 3 would be 4. Alright, so we did product same base, and then we did dividing with exponents. Now we're going to move on to the next law, which is power to a power. So here's an example of what that would look like. Let's say we had x cubed, x being my base, 3 being my exponent. And then let's say that was being raised to another power. So this is what we mean when we say power to a power. So the way this would work is you're going to go ahead and take these exponents right here and multiply them. These guys right here. So the way this is going to work out is it's going to be x, and then 3 times 2 is going to be 6. Yeah, so when you have a power to a power, what we're going to do is just multiply the exponent of the base by the exponent on the outside. So let's go ahead and see why this rule works out the way it does. So this 2 here is indicating that I have 2 of these x cubes, right? That's what an exponent represents. It lets me know how many of this item I have. So it's letting me know I have 2 of them. So let me go ahead and write this x cubed out twice. Right? Because that's what the exponent represents, letting me know I have 2 of those. And see, we're back to the product same base law because we have the same base here and there's a product happening between them. And we said when that happens, we add the exponents. So 3 plus 3. So 3 plus 3 would be 6. And notice we end up getting the same answer again. So that's why the power to a power rule works out the way it does. Alright, so let's just go ahead and do some more examples with the power to a power rule. So let's start with this one right here. It's pretty similar to the other one we did. We noticed that d to the 4th is being raised to a power here. So we're going to go ahead and multiply these guys right here. So d and then 3 times 4 would be 12. And that would be it for that one. So let's move on to a case where you have more than one variable or constant or other things. Pretty much what I'm trying to say is that there's someone else existing here. So we have to consider that also. So it's really not different. You just take this power and you multiply it into each of the exponents of whatever number or variable happens to be here. So the exponent on this guy is 1. I don't know if this is going to look messy, but what we're going to do is take this 5 and multiply it with the 2. And then once we do that, we're going to take that 5 and multiply it with the 1. And that actually does look messy. So what's going to happen is we have this x here, right? So what's going to happen is this power is going to get multiplied with the power that it has. So 5 times 1 is going to be 5. And then for the y, we're just going to multiply its power to the power that we're raising it to. So 2 times 5 would be 10. So it's really not different if the power outside has to get multiplied into different exponents. Okay, so I just wanted to do some more power to a power examples here. So I know I did the multiplication case in the last one, but if we had division, it would work out the same way. So notice that we got a base and exponent, and the power of that base is being raised to another power, and the same thing's happening here with the z. So we're going to go ahead and use our power to a power rule. So this w here, I'm just going to go ahead and write that w there. And what's going to happen is its power is going to get multiplied to the power that we're raising it to. So 3 times 4 is going to be 12. And then here's our z right here on the bottom. And then its exponent, which is its power, since I'm just call it that since we're going with the power to a power rule, its power is going to get raised to get multiplied with this power here, which is the 4. So these guys are going to get multiplied right here. So 2 times 4 is 8. And these are not the same base, so this would be the final answer. I don't have to simplify. I don't have to simplify any further. Okay, let's go ahead and do this one, last one. So this 3 doesn't have an exponent, so I can put a 1 there. That makes me visualize it better. So it's still the power to a power rule. So the 3, its power is 1, and it's going to get multiplied with the power that we're raising it to, which is 3. So 3 times 1 is 3. And then we have the x there. Its power is 2, and it's going to get multiplied to our power, which we're raising it to, which is 3. So 3 times 2 is 6. We can't simplify x to the 6 any further. But 3 to the 3rd power indicates 3 times 3 times 3, right? And that would be 27. So the final answer there should be 27 times x to the 6th.